So we are going to see the subject signals and system. From that subject signals and system, we are going to see the what is signal. So signal is function of one or more independent variable that provides some information. For example, we will be having ECG signal. All those signal it will provide some information. Okay, then we are going to see types of signal. We have two different types of signal: continuous time signal, discrete time signal. Continuous time signal will be in continuous in nature. It will have value at all points that will be represented as x of t. In discrete signal, our value will be having a value at only that particular point, specific point in time. So that will be represented as x of n. And also we will be having classification of signal. In that we'll have periodic and non-periodic, even and odd signal, energy and power signal. So first we are going to see periodic signal. So what is periodic means? It will repeats a value at regular interval. For example, we'll be having sine wave that it will repeats at regular intervals. Whereas what is non-periodic? Non-periodic, it does not repeat at regular interval. Okay, so the steps to find out whether the signal is periodic or non-periodic. For continuous time signal, the steps are the given question in terms of omega. So from that omega it will be equated to 2 pi f. From that f we have to find out time. So that is time period is equal to 1 by frequency. So our equation should be equated to x of t is equal to x of t plus capital T, where this t is represented as period. If it is if this equation, that is x of t is equal to x of t plus t, then the signal is periodic signal. Suppose if the given signal is discrete in nature, then these steps have to be followed. So given question is in terms of omega. So from that omega, that will be equated to 2 pi f. So that f will be equated to k by n. Okay, so that n value will be represented as period here. Okay, so if this f is equal to k by n is rational, then it is periodic. If it is irrational in nature, then the signal is non-periodic. If suppose they have given more than one period, so that time we have to find out LCM of n1, n2, n3 like that. Okay, so these are the steps to find out whether the signal is periodic and non-periodic. So next, so the example for this periodic and non-periodic. See here, the equation given here is sine wave. It will be repeats after a particular interval, whereas this non-periodic, it does not repeat. These are all the example of periodic and non-periodic. Next we are going to see even and odd signal. Even signal is also called symmetric signal. So odd signal is also called anti-symmetric signal. So for even signal, x of t must be equal to x of minus t. This is for discrete. For continuous, x of n is equal to x of minus n. Okay, so here the inversion of time does not change the amplitude. If we are inverting the time, but the amplitude does not change, so that is called even signal. For odd or anti-symmetric signal, the inversion of time, it will changes, it will inverts. Okay, so here we don't have minus symbol, but here we have minus symbol. So that is inversion of time axis also inverts the amplitude of the signal. So this is called odd signal. So if suppose they have given a question, so you have to find how to find out the even part and odd part, then this is the formula. So this is for discrete and this is for continuous and this is for discrete. For continuous, e of t is equal to x of t plus x of minus t by 2. For discrete, x of n plus x of minus n by 2. Similarly for odd, x of t minus of x of minus t by 2, x of n of minus of x of n by 2. Okay, so that this is for continuous signal and this is for discrete signal. So next we are going to see energy and power signal. So how to find out the energy and power signal is, from the given question we have to find x of t. They have given some question, so from that question we have to find x of t, and then we have to take modulus. So the modulus of x of t. After that we have to take we have to find out the limits, that limit ranging from minus t to t, modulus of x of t the whole square dt. After this we have to find whether the signal is energy or power. To determine energy, this is the formula. So limit t tends to infinity, integral minus t to t, modulus of x of t whole square dt. Then energy will be represented in joules, then power will be represented as watts. So for energy, this is the formula. For power, limit t tends to infinity, 1 by 2t, integral minus t to t, modulus of x of t whole square dt watts. Okay. Similarly, this is for discrete. Steps to find out for continuous signal. To find out the signal is the energy signal, this is the formula. For power signal, this is the formula. Also the power signal will be periodic in nature, whereas our energy signal is non-periodic in nature. So for power signal, power is constant, energy is infinity. For energy signal, energy is constant, power is 0. So the example for power signal is u of t, sine signal, cos signal, e power j omega. These signals are power signal. Thank you.